Hi, my name is Charlie from Charlie 101 down in the Florida Keys after a beautiful sunset. Today I'm going to show you how to make this gizmo. What is it, you may ask? Well, this is going to generate a high-speed hotspot from your Android phone that is going to be somewhere between 20 and 50 times faster than the hotspot that you get if you were to connect a device such as your laptop or your gaming machine directly to the Android phone. Now, how does it work, you may ask? Well, in their infinite greed, I'm afraid the mobile phone providers have recently started to throttle the speed that you get from your Android hotspot. They don't want you to be able to stream videos on any other device except for your mobile phone. What this little device does is circumnavigates the throttling that the mobile providers are putting on your device and giving you the full speed, something much, much closer to the speeds that you actually get on your Android device at the moment. So, without much ado, I'm not going to expect you to take my word for it yet. I'm going to test the device in front of your very eyes so that you can see for yourselves what kind of speed boost you can expect to get. Now, this device is made from a Raspberry Pi Zero that costs a mere $10. After that, I'm going to show you how to make one of these wonderful gizmos. Now, I'm telling you, it really isn't that hard, so do stay tuned. Okay, well, the first thing I'm going to do is I'm going to run a simple speed test on the phone. This is the speed, generally speaking, that one would expect to get if we connected our laptop to the hotspot of the Android. Why not? And we see we're getting a respectable 13, 14 megabits a second. Sometimes I'll get 20, 22. It depends on the local congestion and other things, but it's a respectable speed. We don't need to see that one follow through. Now I'm going to run exactly the same test here on my laptop, and my laptop is connected to the Android hotspot of my phone. Now, as I say, one would expect to get a similar speed, so let's see what we actually get when we run that speed test. Okay, well, it bursts at something over 1 megabit a second, but I can tell you right now that that's going to settle down at 0.6. And the reason for that, and I've spoken to, in my case, T-Mobile, is that they say that their definition of 3G is 0.6, which is absolute rubbish. That is 2G. So we are being throttled really against the plan that we're paying for, which is wrong. Now, I'm going to do exactly the same little experiment, except this time I'm going to do it when we connect the phone to the little gizmo, the Raspberry Pi, and we're going to see what speeds we get with that. I haven't set it up, so let me set that up now, and let's do the same thing again. Okay, I've got everything set up pretty much as it should be. I've got the gizmo over here. I've got a small USB cable that's coming out of it and going into my Android phone. I have got a power cable coming over here that's going into the wall. Now, this doesn't draw a lot of current. You could actually run this off the USB port of your laptop, but if I connect it to that, you might think that I was simply tethering the phone to the laptop, which is not what I'm doing. I know it's a little hard to see what's on this screen over here, but we've got a program installed called Easytether Pro. Now, if I put that up to the camera, I think you're going to be able to see that it says connection established. Okay, so that means that it is generating a hotspot. In this case, it's creating a hotspot. I'm going to just push that to one side because I'm going to bring in my laptop so we can do this absolutely in real time, hopefully. And I think if I just move that around, there we go. That's good enough just to do the test so that you can see what's going on. So that is connected, as you can see over here, to Zega 2. And that is the hotspot that's being generated from the same Android phone on the same plan, exactly the same. Let's go and see what speeds we're getting now. There we go. 8, 9, 10 megabits a second. We only got 13, if you remember, when we did the test directly on the phone. So we're getting similar speeds. We get a slight loss maybe because we are creating a full-blown hotspot out of a very, very small little device. But generally speaking, you're going to get speeds that are similar to your phone. So we've gone from 600 kilobits to 10 megabits per second on the same plan. So I think we can all agree that it works. Now, some of you may not have the time or the technical skills to be able to create one of these wonderful little gizmos. If that's the case, don't worry. head over to charlie101.com and I can provide you with a little SD card like this one. Now the SD card simply slots into the side of any Raspberry Pi, a Raspberry Pi 4 or a Raspberry Pi 0W as in this case, and it will be pre-configured with a standard username and password to get you up and running in absolutely no time. So if you haven't got time to follow the rest of this tutorial, head over to charlie101.com and go and get yourself one of these SD cards and you'll be up and running in no time. Before we go on, I think it might be a good idea to have a look at some of the things that we need to be able to get this project up and running. Now here is, if you like, the finished article, which is the Raspberry Pi 0. It could be a Raspberry Pi 4, but in this case a Raspberry Pi 0W. We've got one small connector going to the phone. The phone is running the Easytether software, and the blue cable is running to power. Now this can actually run off the USB port of your laptop. It doesn't draw much power. This one cannot. This one will need a dedicated power supply that goes in here. Now the other thing that's worth noting about these two devices, the Pi 4 and the Pi 0, is they actually have different connectors, which can be quite annoying. This one's got two micro USB ports on it and one HDMI, and this one has got normal USB ports on it, and it's got two HDMI cables. Now the HDMIs are not the same on each of these, which is a bit annoying. So you may need to, if you want to connect directly to either of these devices, go out and get various peripherals. I mean, one of those things being perhaps this USB to ordinary USB, which goes into the Raspberry Pi like that. If you want to avoid doing all of that, okay, there's another technique that you can use, which is connecting to each of these devices in what's known as headless mode. And fundamentally that means that you connect your Raspberry Pi to your local Wi-Fi, you use remote desktop to access it, and you then use the keyboard and mouse of your laptop or your home machine in order to be able to do the final configuration. Now that's not going to be covered in this video because I have put some links down to people that have done a better job than I could do on explaining how to do that. But fundamentally there is an alternative to going out and buying all of these cables, which is to install the software using headless mode. Now the other things that you're going to need, you're obviously going to need an SD card and you're going to need this little sleeve. Apart from that, I think we're all ready to go. I'm going to assume for the next part of this video that you've got the Raspbian 32-bit OS installed on either your Raspberry Pi 4 or your Raspberry Pi 0, and that you've got a keyboard and mouse connected that you can access and control the device from. So assuming you've got that, let's forward wind on to the next part of this tutorial. Okay, without much further ado, let's get on to installing the hotspot to the RPI. When you first log into the Raspberry Pi, you're going to see a screen a bit like this one. We don't need to worry about changing the passwords quite yet, so we can just OK that. Now I'm connected to the Raspberry Pi using remote desktop, and as mentioned before, I'm using the headless technique, which is listed in a link that are in the notes below. So if you want to work out how to do that, it's well explained there. I am connected to my own home local Wi-Fi over the top right over there, if you can see, and we're all pretty much ready to go. Now the first thing that I want to do is I want to open up a Genie window, which is effectively Notepad, and I want to copy into that the commands that we're going to use. So I copy the list of commands from the notes below into this, so that it's easier for us to see what they are and copy and paste them into the command line interface. So there they are, and if they're slightly different than the ones below, then use the ones below because they'll be more up to date. The next thing we want to do is to open up a command line interface. That's how we're going to put in most of these commands, and the most important first two that you want to do is you want to do the sudo apt update, which is going to bring the software completely up to date. We're using sudo because on a remote desktop you do not get root privileges. Now this update can actually take some time, so I'm going to set that going, and when it's done, so we do the sudo apt update, it'll go and have a look at what needs updating, and then after that we do the sudo apt full upgrade, and it'll do that. So I'm going to put the video on pause while that all goes on. I'm going to follow that with sudo apt upgrade. So when we start the actual installation of the Easytether software and the application and the access points, etc., we're going to assume that we've got a completely up-to-date version of Raspbian OS 32. Okay, we've now got a completely up-to-date version of Raspbian OS 32, and we are now going to install the Easytether Pro software. Now we're going to head off to this website here, mobilestreams.com, and we simply do that by going to the built-in browser of the Raspberry Pi and scrolling down to the Raspbian version of that. So Buster or Stretch is the one that I want there, and we click on that and we're going to download it. Now I do warn you that if you're doing this on a Raspberry Pi Zero, it's not really designed for a general user interface. It can be incredibly slow, but once the whole thing is configured, it doesn't use the GUI, so it doesn't really matter. So we're going to wait for, there we go, it's downloaded there at the bottom, so we can actually dispense with the web browser for the moment, so I'm just going to get rid of that. And is it going to harm my computer? We're going to say keep. Oh, continue downloading. So it hasn't actually finished the download yet, so we're just going to wait for that to finish, and then we can carry on with the next part of the tutorial. Okay, so there's the file in our downloads folder. Now you would have thought that you could just right click then to package install from there, but you can't because you don't have the right privilege for some reason when you're using a remote desktop. So we have to use the command line interface to do that, and we need to CD into downloads. Okay, once we're in there, we can go back to our notes, and let's get back to Genie, and what we want to do is to use this command here in order to be able to install that package. So we're just going to copy that, paste that over here, and run that. This one shouldn't take too long, maybe 30-40 seconds. There we go, so that's installed. Right, so we've now got the Easytether Pro software. Now the rest of these things, really, if you just go through them, copying and pasting one by one, it would only take you about five minutes, maybe even less. But I'm going to run through them as quickly as possible and let you know what each of the command does as I do. So the first one is the host APD. This is the access point. This is what's going to turn the Wi-Fi of the Raspberry Pi into something that it is going to give internet rather than receive internet, if that makes sense. It's going to be the access point from which your device, your laptop, logs into. Okay, that's actually done in two parts. The first part is the install of that particular command, and the following command, the unmask hotspot APD, that's the second command of that particular installation that is also required, or it won't work. It effectively adds, as far as I can tell, a few more packages that it needs in order to be able to run. So we can see that there is downloading the required packages and installing them. Let's come back to that when it's done. Okay, I have now installed the host APD. I've run the unmask command, which is actually a very small command. We're now ready to enable the host APD. This is basically going to say that it's going to run on startup, that we don't need to execute anything every time we reboot the device. Once that's done, and I'm going to go over here and copy this command because I don't think that's going to take too long, and we are going to install DNS mask. Now DNS mask effectively is going to turn your device into a router, okay, which is going to provide the IP addresses for each of the connected devices, the DCHP, and all of that sort of thing. So we have enabled that, so we are now going to install this and paste that command in there, and off we go. That one may take a few seconds, so I am inclined to pause the video while that completes. Now it's got a question there. Obviously the answer to that question is yes, we do want to continue, and let it do its funky stuff. Okay, that seems to be done with success. Now the final package that we're going to install is something called NetFilter Persistent. What that does, it ensures that the IP tables or IP tables are which are effectively the routing, the internal firewall is routing the internet through the LAN 0, the Wi-Fi hotspot, and it's ending up at your computer, and it's how the routing of the internet connections are all done. Okay, so this particular package, all it actually does is make sure that when you reboot your device again, that you don't lose your configurations. So that's the persistent part of that. Now that is the only packages that need to be installed, so as soon as that's done, we're going to move on into configuring each of them. So the next particular command, if you can see there over on the left in the notes, is the dhcpd conf file. This is going to be configuring the router, your Raspberry Pi, to now be on a fixed IP address. So once that's completed over here, we'll run that particular command. Okay, that's done, so we can carry on with the configuration of that file, which I mispronounced a moment ago. It is dhcpcd.conf. Alright, now the nano, for anyone who doesn't know, is like a text editor. Sudo nano means it opens up this text editor with this file in it, and you're going to see that it's got quite a lot of stuff in it already. There are only a couple of things that are in white. All the blue ones are hashed out. Okay, now we don't want to remove anything from here. They're all required, but right down at the bottom we need to put in this little section of text here. It's going to basically say that the WLAN 0, which is your hotspot, is going to be configured to the fixed IP address of 192.168.4.1. Now it doesn't have to be that one, you can change it to be something else, but there doesn't seem to be any reason to do that. So we're just going to save that with a Control X. Yes, we want to save it to that, and enter. Okay, so that's actually done. Now over here we're going to make a few a really quick alteration. We want to make the internet forwardable. It's just allowing a certain thing to happen with inside the Raspberry Pi. Forwarding, basically we are forwarding the internet from the Android via Easytether Pro to the WLAN 0 across the radio waves into your device that you're connected. So that's just basically saying we're going to allow the forwarding to happen. So nothing too particularly complicated there. So that again, now that's a new configuration file, which is why there's nothing in it, and what we need to do is we just need to put, that's the only command that we actually need to put into it, the hashed out things there just to let us know where it came from. So we copy that and paste that into the file here, and we're going to save that. Control X, yes, save. Okay, now IP tables, they're complicated to say the least. As I mentioned earlier on, they are effectively the routing system within the router, and this is basically saying that the TUN Easytether, which is now the internet that's coming from your Android via the cable plugged into the Raspberry Pi, is going to be routed off fundamentally to WLAN 0. But this is the command here that we need to put in to make that happen. Now there's a lot of stuff on the internet about how IP tables work, and I have to say that they are quite complicated. So hold on a second, we haven't got the right command there. Let's make sure we copy the right command into place here. So it's not obviously that command which we just copied and pasted before. So let's just get rid of that and put in the correct command there. Bear with me a second. There we go. That's the. It's a very quick thing. It's just adding a line to the to the table that configures effectively it's a firewall. Now, as we mentioned before, this command here, sudo netfilter persistent save, is basically saying if you didn't do that, then every time you rebooted it, it would come back to the defaults. Obviously, we don't want that. We don't want to have to do anything each time the Raspberry Pi boots up, because we're not. When we put it into operation, we're not even going to have anything connected to it, no keyboard or mouse or anything. Alright, so that is giving us a few things. It looks like it has saved what we want it to save. Alright, now, what are we doing next? We're coming over to the DNS DNS mask configuration file. The first thing we're going to do is we're just going to move the original file out the way, so that if something goes wrong we can always put that back. It's recommended in almost every tutorial that I've ever read on the subject, so obviously there are times when that's going to be fairly essential, and so we're gonna do that as well. So all that's going to do, it's just moving it out of the way, moving it to somewhere else, and then we're going to create a new one. So again, we're going to use the Nano text editor there. I'm going to copy that across and paste that in there, and that is going to, now since we moved the old one, that's going to be blank, isn't it? Okay, and we're going to put into it here a few things that are required. It's basically going to say that we're listening on the Wi-Fi connection, the WLAN 0, and then it's going to configure the router to decide which IP addresses it's going to give each successive device that connects to it. So your laptop could get one IP address, your game machine could get another, etc., etc. And it's got a range from 2 to 18 here, so 2 to 20, sorry. So it's got 18 different connections, which is probably plenty for what we need. So we're going to save that. Okay. Now, this command here, which is just in case something or somehow your WLAN is somehow from some other configuration, I don't understand why. Apparently it is good measure just to run this little thing to make sure that your internet, your Wi-Fi on the Raspberry Pi is active. And then finally we're going to configure how the hotspot looks. Okay, so we are going to again open up another text editor, and we're going to put into it the details of the router. Okay, so we're going to just take this text again here, and I'm just going to run through some of the things that are important on there, and we've done that. So we copy that, and off we go, and paste it into here. One doesn't actually need all the configurations that are in this file, so I'm not even going to explain what they all are. You've got your country code. I'm in the Florida Keys, as you know, so it's US. That is your Wi-Fi interface. I have decided to call my Wi-Fi connection megafast, so that's going to appear in your Windows when you try and look for available internet connections. It's going to be called megafast, and then down here the WPA passphrase, I put in 8 M's there just to make it simple. That's the password that you're going to use. I think it has to be at least 8 characters, by the way, so don't put in just 1, 2, 3. I don't think that's going to work. And we're going to save that. All right, we're actually going to go back a little bit because I discovered this a little bit later. What will happen if we don't put in this particular command is that the Raspberry Pi is going to use the DNS servers of your mobile phone company. I'm going to demonstrate that in a little bit of a video later on, maybe, of why this is not necessarily critical, but it's quite a good thing. What it means is effectively that when we do lookups for which websites that we're going to, when it converts it from a name like google.com into its IP address, okay, normally that would use the the DNS server of the, in my case, T-Mobile, of the phone operator. Now, I don't like the idea that my phone company knows all the websites that I'm visiting and all the searches that I'm doing, etc. So this is a little bit of security thing. So this basically, you add it here to the bottom of this file, and basically what it does, it basically says don't use the default upstream DNS server, use ones that I've actually chosen for myself. And in this particular case, I think I'm right in saying that 1111 is Cloudflare and 8888 is Google. So in fact, I know Google do collect information, but this is going to try and go to Cloudflare first. Now you could use 9999, which is another one which does not collect any information on you. But this is the main one. This is the first one it'll try, and this is the fallback. But it will not use, in my case, T-Mobile. So T-Mobile aren't really aware of what I'm doing in the background on the internet, which is probably a good thing. So again, we're just going to resave that, and that is actually it. Now, in order to be able to get everything to come to life on here, we're going to have to do a reboot. I'm just going to show you a couple of things before we do that. Now, you're going to notice, okay, that right at this moment in time, I am connected to my house internet, which is called Zegadope. Okay, I'm connected to it from the Raspberry Pi, which happened way at the beginning of this tutorial in the bits of setting up headless connection to the Raspberry Pi. After I reboot, it's going to be creating a connection for me to connect to. So this is going to change. I'm just pointing out that you're going to notice if everything works properly, we're still going to be able to use a remote desktop to it, but we're not going to use the same IP address. We've now created a fixed IP address for it up here. Remember, we changed it to 192.168.4.1. So what I'm going to do is I'm going to reboot, and we are going to take it from there. So how will we know whether it's working or not after it's rebooted? Well, it's going to be down here, isn't it, in our Windows, and there it is. Like magic, we've got Megafast. Okay, so we're going to connect to Megafast initially now, although I know for a fact that we're not going to get internet connection because I haven't connected the Android phone yet. But let's just see, for theory's sake, to see whether we can make a connection to it. Now it's asking for my password, so that's all looking good. AMs 3, 4, 5, 6, 7, 8, and then it's usually going to ask you, do you want your PC to be discoverable? That's entirely up to you. It's a private network. I'm just going to say yes in this particular case. So it's going to take a few seconds, because the first thing it's going to try and do is try and look for the internet connection. As I say, we're going to connect the phone to it in a second and see whether we do get a high-speed internet connection or not. So I'm just going to pause the video while it does that, but in a minute we're going to see that it's going to say Megafast connected but no internet, which is to be precisely expected at this moment. Okay, so there it is. We can see Megafast, no internet as expected, and we're going to come back onto our connection. As I said, it's now this router is now configured to be 4.1, 192.168.4.1. So let's see if we can get a remote desktop connection, and lo and behold, we can. So now this is on a fixed IP address, and as long as we're connected to it from our laptop, we can always access it in the way that we did before, without having to guess the IP address anymore. And lo and behold, it's worked. We're in. We've got a warning message here, as we had before. Change your username and password at will when required. But right at this moment in time, that's not what we're interested in. We're interested in having a look up here, and you can see that WLAN 0 is now configured as 192.168.4.1. So this is now giving out an access point to our laptop, and it is on. It is a router now. It's effectively a router on that particular IP address. So what I'm going to do now is I am going to plug the Android phone into the Raspberry Pi and see if we can now get an internet connection. Okay, just before we do that, we're going to head over to Google Play, and we're going to install the Easytether Pro software. Now, you've got a number of options here. You've got the Easytether, you've got the Easytether Pro, you've got the Easytether Lite. Now, the Easytether Full is what you want, because that will give you the full functionality. If you go for the Easytether Lite, you won't get HTTPS, which is pretty much useless for any kind of streaming or even email. Everything uses HTTPS. So we're just going to go and get the Easytether Full. Now, it is $9.99, but it is well worth it, and we're going to install that. Now, there's one other thing that you need to do. You need to set your phone into developer mode. So if you go into the network settings and you scroll right down to the very bottom, you're going to see and go down to System. You're going to click on System and scroll down to the bottom again to the About Phone. Now, you need to click the About Phone 7 times in a row. That's it. 1, 2, 3, 4, 5, 6, 7. And after that, magically, you're going to see that some extra functions come up. Now, you need to enter your PIN because it's making sure that that's actually what you want to do. But once you do this, you're going to find that you've got developer options available to you. Now, there's no real downside to doing this. All it's basically doing, there we go, it's the developer options, and we click on that. We've got to do one little thing, is we've got to set the phone into USB debugging mode. Now, all this does, and it's asking you whether to allow it, all this is doing is basically saying that the cable plugged into your USB port of your phone can communicate with another USB port, which is going to be on the Raspberry Pi. So if we now come back to our laptop here, and we can see that we've been disconnected on Megafast. Let's connect to Megafast and see what happens now. Megafast connected, secured. Okay, so it is working. And now, as the final test on all of this, is we're just going to go and have a look and see what the speed is. Okay, I'm running a speed test. And what are we going to get? Nice and healthy. 9, 10 megabits a second on the download speed. This is coming from the Raspberry Pi now, remember. And on the upload speed, we're getting a fairly respectable 5.6. Around about 5. Very respectable. It works. Okay, there's one little tweak that I do recommend that everybody does, and we're going to head over to whatsmydnsserver.com, and we're just going to click in What's My DNS Server. Now, I am logged into the Raspberry Pi that's logged into the Easytether, and we're going to see that it is my local mobile phone carrier. Now, I don't really like that. That means that my local mobile phone carrier is basically knowing pretty much everything that I do on the internet, and I think that that doesn't provide me with a great deal of security, so I want to change that. Now, in order to make this change, one just needs to go back into a remote desktop session of the Raspberry Pi and open up the command line interface and go back into the dnsmask.conf file, and we need to add 3 lines really. This is the no resolve command, which basically says it's not going to allow the Raspberry Pi's normal configuration to take control of the DNS servers. And in here we can put in whichever DNS servers we like. Now, I've chosen 4.9.9999, which comes from the 4.9's company, and 1.1.1.1 that comes from Cloudflare, because both of these companies do not collect personal information when you use their domain servers. And what we need to do is we need to save that, and we need to exit that and reboot. And when we reboot, we're going to do that same experiment again. Okay, if we now go back to whatsmydnsserver.com and we rerun the test, let's see what we get. What I notice actually doing it with these, we get WoodyNet. Now, WoodyNet is in fact the 4.9's DNS server. I've actually done this a few times, and if we do it again, we might get the Cloudflare. They're basically both working in tandem, so we'll get one or the other. But we do not, there we go, we do not get T-Mobile's DNS server. That means they're not tracking our movements, so that is an added level of security. Anyway, I think that comes to the end of this tutorial. The notes are below for you to be able to copy and paste all the commands and do this for yourself. And do remember that if you don't want to go through this whole process, it can be a little bit daunting for some people, then you can simply buy the SD card from me and I will send it to you with all the configurations that we've got here pre-configured, and you can just slot that in. And with a few fairly simple maneuvers, you'll be able to change that password if you're concerned that your neighbour's going to find out what it is and that sort of thing. But generally speaking, it will work straight out of the box. So I hope you've enjoyed the video. Do join my channel if you feel inclined. I've got lots of really good stuff coming up.